arrow से जा रहा है. So these are the reasons by which you can improve your studies. You can incorporate many clear parameters, and then it comes out to be a good study. Spomodal patterns. If you do not have much, you just count upon the cells under section or as a whole mount under phase contrast or stereo zoom and go for scanning. And all structures, they look very different. And you can of course see spomodal pattern में बहुत कम काम हुआ है, बहुत कम काम हुआ है. Mecanopsis, papaver, solanum nigrum, that is only genus Solanum, and much of the work is not been done on the seeds. Move for the spomodal pattern. You get a better one and correlate it with other information which are available, maybe of stomata, maybe of anatomy, maybe of any oil, wax or something else which is available, and correlate the structure. And when you take the parameters of this, actually the scanning electron microscope से उसके अंदर वो आता है, scale आता है. आप मेजर कीजिए एक सेल की लेंथ एंड विड्थ एंड डेप्थ, आप उसमें मेजर कर लीजिए, पुट द स्टैटिस्टिक्स एंड योर डाटा इज वेरी गुड correlated. Correlate with anything you have with you, and that would give you a good result. इसमें टाइपर लगा नहीं, मैंने कौन सा खोला हुआ है? ये है टाइपर. Just showing a few of the images, that's it. Look, this is the vasculature of the flower. When you cut from the microtome, you will get, if you cut a longitudinal section in this particular picture, you can see all the vascular bundles. They are going up or down, which way they are supplying to. If you have a plant with inferior ovary, cut a longitudinal section, you can see the supply of it. And the first one, that is the C. If you see even B, you see that is the portion of the pedicel, and in the portion of the pedicel you have, because it's a stem, you will have conjoined collateral bundles arranged in a ring. If you see C, you can see there are 5 vascular bundles which have moved towards the periphery. Naturally, they are the sepal bundles. You move on to the next one, you can see the sepal traces. The 2 laterals have also appeared in, and the rest of the bundles are trying to organize. And if you move on that way, and ultimately you will be able to see. Here you can see the sepal has completely separated. Here you can see the antecium petals have started appearing, but the stamens are still there because this is an epipetalous one. This is a solanum. So naturally it belongs to gamopetally, and there is an epipetally with stamens. Hence the tube will move for certain length. Certain length can be 1 cell thick, 2 cell thick. If it is a corolla tube like Natura, like Physalis, or like Nicotiana plumaginifolia or Apocynaceae, there will be a huge long tube which will be available. You keep on cutting the sections, and ultimately you can see the vascular traces which are there. You can also see all the 5 stamens which have got opened up, but you can just see that everywhere the macrosporangia are not as yet clear. They are under formation. So this I wanted to just show you that this is how we can use. These are all cameralucidal drawings. These drawings are cameralucidal drawings. So this is true to the cell size. Because I wanted to make a line diagram, so I have made a line diagram. So these are all hand cut sections. This I wanted to show you. SEM. This is a section of Syngopogon. We cut the section and had taken to scanning electron microscopy, and now we have all the parameters including the depth of each of the trabeculae, each of the erenchyma, because this stem is complete structure. ये एक पूरा channel है, cylindrical structure है. So naturally ये channel complete जाएगा नीचे तक, and you can just see here. If you see carefully, all these metaxylem are also showing a thickness, a depth दिखाई दे रही है, because it's a scanning electron micrograph. So all these, if you add to your paper, they become too much. and everybody would say, okay, you are able to decipher it, and if you cut a hand cut section, put it on it, the same plant, same magnification, they will superimpose with each other and your parameters are all true. These are few of the floral diagrams. You study it everywhere. I am not showing all because this I have picked up. Convergia alata, where you have a didynamis condition. You ask anybody what is a didynamis condition. Two stamens two stamens are long, two stamens are small. What do we mean by this? What do we mean by two stamens are long and two stamens are small? In fact, two anterior stamens have got longer filaments than the posterior stamens. If you say two stamens are long and two are small, that means you are talking about antelopes, which is not the truth. Truth is only anterior filaments are longer than the posterior filaments, and that is what is important to explain. And what happens, we do not concentrate on such things. Even if we draw euphorbia, cyathium inflorescence, and we try to draw a mother axis. Inflorescence ka mother axis kaise ho sakta hai? We are not supposed to draw mother axis for any of the euphorbias when we are talking about cyathium. You ask anybody, euphorbiaceae में क्या inflorescence होता है? Cyathium होता है. Cyathium is only present in one genus Euphorbia, and the family is too big. Basically, cymos is there. So these things are sometimes become misnomer. I don't know why, but the understanding is such. That should not be always be repeated and should be taken care of. Like we say, Acaranthus aspera. Alright, the other day in Hastinapur also I was asking, I do not know, Sandeep was there I suppose, whom I was saying, if you see Acaranthus, the top flowers are up. That is spike inflorescence, the proper spike. You see the bottom, every flower is topsy-turvy. And when it is topsy-turvy, say if this is the mother axis and if the flower is attached like this, it gets back like this. So what will happen? The bract will go towards the side of the mother axis. Hona kya chahiye? The bract is away from the mother axis. So when children take out the flower from the base, so madam isme to bract jo hai towards the mother axis hai. वो हो नहीं सकता. And if you see carefully, they are topsy-turvy, hence the mother axis and the bract are on one side. That does not mean that you draw the diagram accordingly. And normally, if you see these fimbriate sterile staminodes which are there in Acaranthus, if in such cases, wherever you have a fertile and sterile stamen alternating with each other, we should call them as interposed staminodes. They are all my hand drawings. सारे फ्लोरल डायग्राम मेरे बनाए हुए हैं. They are called interposed staminodes. You cannot call them as alternate staminodes. Alternate to what? If you say interposed staminodes, it clearly indicates एक fertile, एक sterile, एक fertile, एक sterile. So Amaranthus have got Acaranthus, Alternanthera, Gomphrena, Amaranthus. अगर इसका आपको एक की बनाना है, Amaranthus is unisexual. एक साइड में चला जाए, तीन अलग चलेंगे. If I say only, and even Celosia, the fourth one. And then, if you talk about Acaranthus, it's a spike with spines. You move ahead with something else, say Alternanthera. Alternanthera and Gomphrena have got monothecal anthrolobes. You can just put them together. Celosia is different. If you cut a transfer section passing through take a placentation, you will find a free central placentation. Half the local books, as my students, they tell me, they write free central placentation. Wrong. You do not have free central placentation or other than basal in Amaranthaceae. But what happens in Celosia? Celosia is entirely different. Celosia has got on a basal placenta many ovules. You cut a longitudinal section, you will find that many ovules are attached like this. And since you cut a section like this, it will give you many ovules like this, indicating thereby it is a free central placentation. आधे से ज़्यादा books में लिखा हुआ है कि free central placentation है, नहीं है free central placentation, सिर्फ basal है. मैं अपने उस experience से भी कह रही हूँ, मैं हायर एजुकेशन कमीशन में और दूसरी जगहों के कमीशन में भी एज एक्सपर्ट जा चुकी हूँ. मोस्ट ऑफ द टाइम अगर बाय द वे ऐसा कोई सवाल बीएससी लेवल का पूछ लिया गया तो मामला गड़बड़ा है. जिसको कि एग्जामिनर सोचते हैं हमने बहुत सरल सवाल पूछा है, it turns out to be a very difficult question to answer. So these are certain, rather you can say, shocks which you always have to remember. If you are going for any interviews, if you are going for any presentation, these are certain things which if you keep in your mind, I think the interviews are then fine with. बहुत छोटे सवाल होते हैं जिनके जवाब हमारे पास ज्यादातर नहीं होते हैं, like simple and compound leaf. If somebody says you are having a degree in simple and compound and in botany and you do not know simple and compound leaf, it's not a good answer. And at the same time, तुरंत ही जो एडवाइजरी बोर्ड होता है, जो एक्सपर्ट्स बोर्ड होते हैं, वो चिढ़ जाते हैं, कुछ नहीं आता, छोड़िए छोड़िए, इनसे नहीं पूछा जाएगा, इधर से भी बात नहीं पता, जबकि ऐसी बात नहीं है. हो सकता है वही एक सवाल नहीं पता था, बाकी मालूम हो सकते हैं, मगर एक इंप्रेशन तो आ गया ना गड़बड़. तो जैसे हम कहीं जाते हैं शादी ब्याह में, सज बज के निकलते हैं, तो सज बज के निकलिए कि कम से कम जो बेसिक सवाल है वो पूरे हमें आते हैं. हमारा सब्जेक्ट तो हमें आता ही है जिसमें हमने थीसिस करी है, उसमें तो हम हैं ही एक्सपर्ट, हमने थीसिस उसी में करी है, क्यों नहीं आता होगा, बिल्कुल आता है हमको. सो ये छोटी चीजें बहुत इंपॉर्टेंट है. दूसरी बात, अगर आप एमरांथिस किसी को करने के लिए क्लास में देंगे, तो अगर आप उसको ऐसे लाइट में देखेंगे तो ऐसे घूमता हुआ चलता है, राइट. Each node has got 7 flowers. It is a dichasium. I'll show you a picture of it. Alright, I'm not able to lay my hands on. There are many. Just make a small drawing for you. What do we understand by dichasium? There are 7 flowers. That is a central flower. All are sessile, and there are 2 flowers. Okay, dichasium hai, even another 2 smaller flowers like this. Whether it is a male inflorescence or a female inflorescence, this is a dichasium. Okay. Now, because it is Amaranthacea compulsorily will have bracts and bracteoles. What do you find? You find a structure like this. This is the mother axis. होना कितना चाहिए? Each flower should have 1 bract and 2 bracteoles. Instead, when you count upon it, you are going to find only 7 such structures which are there. Why? Because the bract of this is bract. These 2 will act as bracteole. For this is a bract, these 2 are the bracteole. For this is a bract, these 2 are the bracteoles. Hence, instead of 21, you find 7 bracts. 7 bract-like structures. Although we will say each and every flower is bracteate as well as bracteolate. So these are, because there is no pedicel, these are all spiked. They are so clumsy and rather you can say tightly pressed to each other that there is no space which is left. And that's how we have this kind of a structure. So these are smaller things which I really wanted to tell you. We had made some of the slides, Farzana can show them. We made some slides of stomata to show you different types of stomata and the relationship with the epidermal cells. But I am sure all of you know how to take out the stomata and the epidermal cell. Certain things which I believe that if the teachers are good at, they would not feel any problem or they will not have any problem of teaching the subject and saying that taxonomy is taxonomy. So taxonomy is a very interesting subject provided you understand it properly. Thank you so much.